Hello students, hope you all are doing well. Here in this video, we are going to take a look at another block you find in inorganic chemistry. In inorganic chemistry, it's three blocks are there. What are those? S, P, D. So, out of those three blocks, it is the P block that we are going to find it out. Or we could call it, it's the introduction made on P block chemistry, P block elements. So far, we paid our attention on the earlier block, first S block. There you found out some unique properties of those elements representing S block. It was first, second groups in the periodic table that you found out there as belong to S block. Then if we are going to find it out, what's there we are having in here in P block. And we are going to compare these P block elements with S block and D block. Students, in the S block, first and second group, those elements are exhibiting, all are metals, those are exhibiting fixed valencies, fixed oxidation states. Then when you compare those with D block elements, they are exhibiting, most of them are exhibiting multiple oxidation states as well as multiple valencies. So here also in P block, most of elements are showing multiple oxidation states as well as multiple valencies. Then students, when you check these elements, it's in the periodic table, in the S block, you would find that most of them are metals. Then all the elements they are in D block, all of them are metals. Those also are metals. Then students, this is special. What is special? This P block is special. It is having all the non-metals in the periodic table. You could call that. All the non-metals in the periodic table could be found out here in P block. So then anyway, though P block is having all the non-metals in the periodic table, it is not only non-metals you have having here in the periodic table. You have in P block here in the periodic table. You have metals as well found in P block, but all the non-metals you could find here. Then students, you could expect therefore non-metallic character exhibiting elements here in P block. Then we have this kind of a property or this categorization as metallic non-metallic character. Do you know what exactly this metallic non-metallic character stands for? Metals are having some unique properties as metals could conduct electricity as well as heat. Metals are ductile, malleable, emitting sonorous sound when you beat on them. And metals have metallic lusters as well. Then students, those opposite properties of those metals, if any element or elements are having those properties, we call them non-metals. So therefore, we could clearly categorize them into two categories as metals having those unique properties and non-metals having totally opposite properties of metals. Then sometimes you would be able to find it out. Some properties of both, like bit of metallic properties as well as bit of non-metallic properties exhibiting. Then we call them metalloids. Then when you categorize those into all three types, then some few elements are still remaining. We call them noble gases. Then students, it's based on their, let's call, physical properties. You could categorize these elements into metals, non-metals, metalloids and noble gases. So it's based on physical properties. Then when you check for their chemical properties of let's say their oxides they form, then it's a general fact. Metallic oxides are basic. Non-metallic oxides are acidic. Then is that kind of thing like metalloids oxides something else? No, it's not. It's students, this is a general fact. It's metals generally form basic oxides. And non-metals generally form acidic oxides. Then this was being used for long time period. So if an oxide was acidic, then we could have a kind of a reason to suspect whether it's a non-metal form this acidic oxide. Then if it is a basic oxide that you experience there formed by an element, so then it's fair reason that you would suspect it as whether it has formed by a metal. Then students, when it was being applied for long time, then they started thinking oppositely, in reverse way. If an oxide was found out exhibiting basic character, it was called the element was a metal. It is a metallic oxide. It's the same thing applied in opposite way. If now it was that emphasized the fact that generally metals form basic oxide and generally non-metals formed acidic oxide. Therefore, in reverse way also they started thinking. In reverse way, it was like if it is basic, the oxide's character, they started saying that it is a metal, the element. It is a metallic oxide, that's why it's basic in character. Then, if it was found out it is acidic, the oxide, then they started saying, it could be a non-metal. Then students, with that application, they found another type as well. There were some oxides having basic properties as well as acidic properties with the same. If you find some species living in water and land to both, you call them amphibians. So, having basic properties and acidic properties both, they are in the same oxide. Those were named as amphoteric, amphoteric oxides. Then there was another type of oxide based on their chemical characteristics. It's acidic, basic and amphoteric, having both properties. If you find none of those properties, then it's neither acidic nor basic properties are having here. It's neutral oxides. Then students, it was based on their oxides characteristics, chemical characteristics. Those oxides could be seen named as acidic oxides, basic oxide, amphoteric oxides and neutral oxide. Then in the reverse way, they started naming those elements which formed acidic oxides as non-metals. Then those elements which formed basic oxides were named as metals. Then it could be seen with some elements, actually some metals, both properties. Both properties means both acidic and basic properties. Then those were named, according to the oxide's name, those were named as amphoteric metals. Then, except these, what else you have are noble gases. Students, it's my point is, based on their physical characteristics as well as chemical characteristics of oxides they form, elements could be named into metals, non-metals based on two contexts. You have the same word or same name, metals being used in two contexts, as well as you have the same word, non-metals being used in two contexts. Therefore, you need to be very, very careful to find it out, figure it out. What is the context now? They are calling this, what is the basis? Now they are calling this as a metal or non-metal. Okay, so my point is there are two categories or two ways you could categorize them as metals, non-metals. So based on their physical properties of the element, based on their chemical characteristic, chemical properties of the oxide form. So, if you could categorize them as metals, here the metals are the elements that have electric thermal conductivity, conductors exhibited. So, and ductile, malleable, metallic luster, and sort of the sound emission. So, those are metals. Then opposites are non-metals. The others are non-metals. Then exhibiting in-between properties means part of metallic characteristics as well as part of non-metallic characteristics. Those are metalloids. Then its others are noble gases. Noble gases. Then students, it's another type of metals, non-metals, another category, and noble gases you could have. Noble gases are the same for both, and metals here were the elements which formed basic oxides. With the fact that generally basic oxides are formed by metals, those elements which form basic oxides were named as metals. So, it's mostly you would find that same metals here you find as exhibiting those properties, physical properties, forming their oxide being basic, those would belong here as well. But the reason I am giving you this is there are sometimes there are some deviations followed. Okay, let's find them now. Then students, it's here non-metals. Non-metals here are the elements which form acidic oxides. If you find the oxides, all of oxides being acidic, the element could be named as non-metals, non-metal. Okay, then students, it's some oxides got both acidic character as well as basic character. Those oxides were named as amphoteric oxides. So, if all the oxide formed by an element are amphoteric, again, if all the oxides, those elements formed, an element formed all its oxides as amphoteric, then the element could be named as an amphoteric element. Amphoteric element. So, those elements which form, they are all oxides with amphoteric characteristics called amphoteric elements. Others are noble gases. Therefore, when you name them as metals, it's now you have two contexts to think about. If you feel it like now they are saying these things or naming these things based on their physical properties of the element, then metals are those elements which have got electric thermal conductivity, ductility, malleability, sonorous sound, and metallic luster. Then non-metals are the elements that exhibit totally opposite character. Then metalloids are the elements those which have got both properties. It's quite like boron, germanium, silicon. It's those would conduct electricity as well as those exhibit non-metallic characteristics. So, then therefore those elements could be named as metalloids. Then students, it's noble gases. You find helium, neon, argon, krypton, xenon, radon. Then vice versa, when they have started using the other way of this same concept, they found it based on their properties of the oxide. The properties of the oxide was the basis for naming element there as metals, non-metals, and amphoteric, not metalloids you get there, and noble gases. Then if you find any element forming all its oxide being basic, it's a metal clearly. Any element forming oxides, all the oxides as acidic, it's non-metal. Then if you find all the oxide formed by an element being amphoteric, the element is an amphoteric metal. Then others are noble gases. Here also helium, neon, argon, krypton, xenon, radon, those who do not form oxides. Okay, then hope you find the difference between those two categorizations or bases, or we could call them the context, different contexts. Okay, here on those elements found in the periodic table you would categorize as metals, non-metals, metalloids and noble gases based on this context, physical properties of elements, and as well as metals, non-metals, amphoteric and noble gases based on this context as their oxides properties, oxides chemical properties, based on oxides chemical properties. Then students, it's very clear those two terms like metalloids and amphoteric metals do not tally each. It's, if you hear the word metalloids, then it's for sure they are using this context. It's this, based on this context the categorization is done. If you hear the word amphoteric, it's very clear that it's based on this context only they are doing their categorization of those elements. Okay, then having that in your mind, let's go through this P block that you find in the periodic table. Okay, now I'm about to give you those P block elements. Students, in the P block, it is you are having those groups 13 to 18. In 13 to 18, 14, 15, 16, 17, 18. Those all the groups belong to P block. For the reason it's their elements have got their final electron being filled into a P subshell. That's the definition. If you have got an element, its final electron has filled into P subshell, that could be named as a P block element. In the periodic table, it's 13th, 14th, 15th, 16th, 17th, 18th. Those groups, 6 groups, belong to P block. Then let me show you those. It's 13th, 14th, 15th, 16th, 17th, 18th as well. Then students, in 13th group, you have these elements: boron, aluminum, gallium, indium, thallium. Then it's in 14th group, you have these elements: carbon, silicon, germanium, tin, lead. In 15th group, you have nitrogen, phosphorus, arsenic, antimony, bismuth. In 16th, it is you have oxygen, sulfur, selenium, tellurium, polonium, other elements found. Then in 17th group, it's fluorine, chlorine, bromine, iodine, astatine, are the elements found. Then in its 18th group, it's you could keep helium also here at the top, helium. But helium, its electronic configuration is 1s2. Its final electron has not got filled into any p subshell. Therefore, though helium is considered as a noble gas, we do not consider it as a p block element. So the p block here starts in 18 with neon, argon, krypton, xenon and radon. And helium is not considered as a noble gas. Then students, when you check for these elements, they are, let's base on the physical properties of the element. Physical properties as I have already shown you as electric thermal conductivity, metallic luster, sonorous sound and ductility, malleability. If any element is exhibiting such all properties, we call them a metal. That element is a metal. Then if it is not if it is totally opposite properties you could experience, it's a non-metal. Then if it is in between properties you get there, it's a metalloid. Then others are noble gases. Others you have here, the noble gases. Then students, they are starting from Goro. We could draw it this thing. It's a staircase, let's say. So if you could draw such a staircase, then the first element and the last element are metalloids. They are down there. So then other couples are metalloids. Other three couples are metalloids. These students are the metalloids you formed. Metalloids exhibiting both metallic and non-metallic character. So then it's silicon and germanium you could find we use there in semiconductors as well. These are the metalloids. All the others you find here are non-metals. Then all the other you find there are metals. So in that way you could name them as metals, metalloids and non-metals. It's very now clear that they change their properties from metals through non-metalloids to non-metals. So that's what you get. So you need to clear that out. We have not based on that context of their properties of the oxides they form. If we have not based on that, it's something else. It's another context. Okay. Anyway, now it's very clear. You could find all the non-metals in the periodic table. They are in this block. It's the P block. Then students, it's further. We are going to study at least one of those each group element. They are under P block. So if we are going to pay our attention mostly here on aluminium under 13th group. Then next we are going to discuss carbon's property or carbon's chemistry under 14th group. If we are highlighting one element mostly. Then under 15th group it is nitrogen, the element. That spotlight is placed on nitrogen, right? Spotted on nitrogen. Then it is oxygen and little bit of sulfur as well. It is mostly oxygen we talk there about. It is mostly chlorine and it's all the elements properties in patterns we are going to talk about. There are reactions that you find in patterns. Those also we are going to find out there, but it's mostly chlorine. So there it's mostly helium. They do not form compounds much, but it's helium we would be talking about. They are in that group, 18th group. Then students, learning P block chemistry. If we are going to find it out more details or more chemical, physical characteristic properties, reactions they exhibit. They are aluminium, carbon, nitrogen, oxygen, little bit of sulfur and chlorine and xenon. Those are what we are having. They are in the block, in the P block. So from next video, if we are going to talk about those each group elements, basically it's paying more attention on these elements that circle. Okay, hope now it's this area, this field, this P block is little bit of kind of you might have got the idea of what you are going to find there out, figure there out under each group in the P block. Okay, students, with the hope to meet you in our next video talking about the reactions, properties of those P block elements starting with 13 group. I'm going to wound up here in this video. Okay, hope you could understand this small simple thing. Okay students, goodbye.